In the 7.2 set, we're back to doing more constructions. Now in these ones, we won't be doing the rhombus. On the number 5, they want us to construct a parallelogram. And it says, given that side XY, side YZ, and angle XYZ, they want us to have these three things in the parallelogram. So what do we need by definition of a parallelogram? How do we make a parallelogram? Well, we need parallel sides. We need two pairs of parallel sides. If you think about the properties though, the opposite sides are also congruent. And that's how we'll probably construct this one. We're gonna go ahead, we're gonna take that little side ZY, and we're gonna move that length over to angle X. We're gonna find this short side, where would it go on angle X? And then we're gonna take that big side on the bottom, Y is X, and we're gonna move it up top with angle Z, and we're gonna figure out where that side would fit in. And the way we're gonna figure those lengths and figure where they fit in is using our compass. So we need to set the compass. We need to figure out how do we move that small side, that side YZ, over to X. So you're gonna take your compass, put the point of the compass at Y, and set it to Z. Setting the compass, we wanna get that radius equal to that short length. When you have your compass set, go ahead and draw a circle centered at Y. Now we're gonna move that circle over to X. We're gonna take our compass, we're not gonna change the radius, we're gonna move that length over by drawing a congruent circle over at X. So take your compass, move the point of the compass over to X, don't change the radius, and draw a circle centered at X. Now that last vertex is somewhere over there on circle X. That's all the points that are that same small side distance from X. But I need to find where those points would also have to be, where it's also going to be the same length YX, but centered up at Z. I want to take that big side now, and I want to move it up to Z and figure out where it crosses that circle. So this is going to involve resetting the compass. We're changing from the small side to the big side, so now we need to open up that compass. Take your compass, put it centered at point Y, and open it to where it's open to point X. So set your compass, point on Y, pencil on X. Once you have that, go ahead and draw a circle centered at Y that's going to go through X. Now we want to take the circle and we want to move it up to Z. We want to take that length and we want to move it up so we can figure out where that point is that's going to be that same distance as YX is, but from point Z. So take your compass, don't change the radius, move the point of the compass up to Z and draw that circle. We want to figure out where this new purple circle intersects the small circle that was centered at X. So take your compass, move it up to point Z, and let's redraw that big circle. Where does that fourth vertex intersect? Where is it going to be the correct distance from Z, but also the correct distance from X? Well, it's going to be that point up top where the red and that last purple circle intersect. There's the same distance from X for the short side, but also the same distance from Z for the long side. There's my missing piece. Now that I have that, I can draw in the parallelogram. Number 6 is going to be kind of the same idea. They want us to construct a line parallel to QT, so parallel to that given segment that they gave us down there, but they want it to go through point R. They want us to draw a parallel line, but moved up through point R. Well, if we need to draw parallel lines, what shape will help do this? Well, the parallelogram would probably be the best one. Parallelogram had parallel sides. So how are we going to do that? Well, we're going to do what we just did. We made a parallelogram. Parallelograms have parallel sides, so we can just turn this into a parallelogram. Now, it's not quite the same things that they gave us because they gave us the segment and a point, but they didn't give us that second side. Well, that's what you're going to do. You're either going to make Q to T or QR that other side. So we can use the QT, so let's just leave that what it is, and then connect either QR or RT, and we'll make that second side of the parallelogram and just go through the same steps. Right? If we take this as one side, and for instance, let's say I'm going to make QR my other side, so it looks like that previous picture, now I can just go through and redo the steps. Set the compass, set it to QT, draw a circle. Move the compass over to T and draw that same circle. Right? That'll be all the possible points from T that are the big length. Take your compass, set it to QR, draw a circle. Move that circle over so where the point's now on T and draw it. Figure out where it's going to be that same length. Okay, so just go through the same steps, and that's how you're going to do that. Now, number 7 down below is a little different. That one's asking for, given segment AB, we want to show all the points C such that ABC could be an isosceles triangle. Well, what is an isosceles triangle even? Well, that's a triangle that has 2 equal sides. So we want to make this one side of a triangle that's going to have 2 more equal sides. How can I do that? Well, I need a point up top or down below that's going to be in the middle of AB. Right? It's going to be either above or below, but above that midpoint. Hey, you know what? Think about it. When we did that one of the previous homeworks in 7.1, we figured out how to draw a perpendicular bisector, something that goes through the midpoint. Well, we're going to repeat that process. But instead of having to draw all of the circles like we did in 7.1 ready, we can just pick one circle, draw it at A, go over to B, draw that same congruent circle, and find where they intersect. Okay, so if we draw a circle, and it has to be just something bigger than halfway across. If it's not bigger than halfway across, the 2 circles won't touch. So I pick something a little bit bigger than halfway across, and draw that same congruent circle, but now centered at B. And I think you can see one of the possible, actually 2 of the possible points. If you draw the perpendicular bisector, anywhere on that segment could be that missing point that you need to make it into an isosceles triangle. Okay? So you're going to go and draw your perpendicular bisector in like you did in the 7.1 ready, and then anywhere on that new segment or that new line could be a point that would make this into a triangle that's isosceles. All right, I'm going to let you try the 8. Number 8, I'll let you try that one on your own. Let's see how you do with that. Okay, good luck with that.